And in this problem, already the graph is supplied to us in the form of the question, and we are being asked to uh, make all the 7 matrices, right? So this is what we were expected to be doing in the last numerical. So I will just solve this numerical one by one with all the matrices. Those who have, they can cross check their answers with my answers. Those who have not solved, they can go through the problem, and so that next they can solve accordingly. Okay. So let us start the problem. And one more thing which was given to us, already the graph was supplied to us, and in the graph itself, as it you can see, the dark lines are element number 1, 2 and 5. That's why I have written here the branches as 1, 2 and 5. So those 1 and 5, this is the branches, and 3 and 4 is the links. This is as given in the problem. Okay, we have not taken this branch and link by our own, but it was given to us in the problem itself. That's why we have taken this branch and link. Otherwise, if the branch and link was not provided to us, then it is our autonomy to take the it is our choice to take the branch and link according to our wish. Okay, but as in the problem itself, it is given which element is to be taken as branch and which element is to be taken as link, because they have given us, see, you can see here with the dark lines are considered as branches, dotted lines are considered as link, right? So dark lines are 1, 2 and 5. That's why we have written here branches as 1, 2 and 5, right? Then link, it is given with the dotted line. That's why we have taken 3 and 4 as link. Now let us fill the element node incidence matrix, which is denoted by A and a dot over it. A dot is equal to 1, 2, 5, because first we need to write the branches and then we need to write the links. Now let us fill one by one the columns. How to fill the columns? Let us see. So first we need to go to the column number 0. So what is column number 0? For filling the entries in the column number 0, we need to go to the node number 0. So this is the node number 0 to us. So we have to go to this node number 0, and in this node number 0, what we need to do is we need to check what is outgoing and what is incoming, and how many elements are incident over this particular node. So in this particular node, the elements that are incident are 1, 5 and 3. We have to take always the thumb rule for filling this particular entries as outgoing, positive, incoming, negative. So you can see here what are the outgoing elements. Outgoing elements are 1 and 5, and incoming element is 3. So outgoing, I will take here 1 and 5 as positive, and 3 as it is incoming, I will take it as negative. Okay, is this clear everyone? 0 part. Next, for filling the entries in 1, I have to go to the node number 1. So where is node number 1? This is node number 1 over here. So in this node number 1, let me check what are the elements which are either incoming or outgoing. So we can see that 1 and 4, these are the two elements which is incoming to this particular node 1. So I will take this 1 as -1 and this 4 also as -1. Why? Because 1 and 4 both are incoming to this particular node. So in this way, I have completed the entries of this column number 1 also. Now let us fill the entries of column number 2. So for filling these entries of column number 2, where we have to go? We have to go to the node number 2. So node number 2 is here. So in this node number 2, what are the elements incidents? Just check it out. So elements that are incident are 2, 4 and 5, out of which this 2 and 4 is outgoing and this 5 is incoming. So what we have to do here is we have to put this 2 and this 4 as positive and this 5 as negative. So always check this, that outgoing should be positive and incoming should be negative. And finally, we have to fill the entries of the column number 3. So column number 3, for this we have to go to this node number 3, and in this node number 3, this 3 is outgoing and this 2 is incoming. So 3 we have to make it positive, and this 2 we have to make it negative. So in this way we have completed all the columns, and whatever point is left over, we have to simply put it 0. So let us make 0 to the rest of the uh, parts. So this, so remaining part we have to put it 0. So we will put the zeros over here in our element node incidence matrix. So once we are done with element node incidence matrix, what we have to do is we have to verify whether the summation of all the bits, see, this is 0 plus 0, then 1 minus 1, that is again 0. So that means row number 2 is also correct. Then row number 5, if you will check this, 1 minus 1 0, that means this is also correct. Row number 3, minus 1 1, this is also correct. Then for this particular row, minus 1 1, this is also correct. So this is the mechanism how to cross check whether the entries that you have done in a particular matrix is correct or not. Okay, so in this way we have completed the first bit, that is finding a dot. Now let us focus on the second bit, that is a, which is given as the bus incidence matrix. So for writing this bus incidence matrix, what we have to do is simply we have to eliminate the column number 0, or in other words, the reference column we have to remove. So if we remove the reference column, how the matrix will look like, let us see. So 1, 2, 5 and 3, 4. These are our elements. And why we are writing in this sequence? Only because 1, 2, 5 is our branches, and 3 and 4 is our link. That's why we are writing in this way. If we would have taken 1, 2, 3 as branch and 3 and 4 as link, then we could have written in the sequential manner, that is 1, 2, 3, 4, 5. But as in the problem itself, 1, 2, 5 were branches, we have to write this as 1, 2, 5 only. We cannot write it as 1, 2, 3, 4, 5. Is that point clear to everyone? Because in the previous problem we have taken 1, 2, 3 as branch and 4 and 5 as link. That's why we had written in that pattern in the previous problem. So please don't get confused. There will be variety of problems in this particular subject. You have to solve all such problems. Then you will build up a confidence among you to solve any type of problem and to solve any type of question. Because if you will solve the MCQ based question also, then also this type of questions will be asked, and they will give you the alternative option as A, B, C, D. So in order to fill that A, B, C, D, you will have to solve the problems, and then only you will get the correct answer. So here you can see that in bus incidence matrix, what I have done is I have eliminated the 0 column, that is the reference column is not present, and rest all the things we have to copy it from the previous matrix that we have written here. So in the previous matrix, 1, 2, 3 is in this way. So what I will do is I will simply copy the entire content of 1, 2, 3 from the previous matrix. So how this will look like, let us see. So first I will put the first column. So the first column is in this way, 1 and minus 1. Then let us see the second column. So second column is 0, 1, minus 1, 0, 1. So I will put the second column in this way, 1, minus 1 and 1. This we have to copy it from the previous matrix. So we have to be very careful. If we are not writing it the things properly, then our matrix will become wrong. And what about last entry? Last is in this way. So minus 1, 1 based on the previous matrix. So no, minus 1, 0 and then 1, 0. Minus 1, 0 and then 1, 0. So this is your bus incidence matrix, which is denoted by the alphabet A. So this is the answer of your second bit. Okay. Now let us write the answer of the third bit. So third bit is K matrix, that is the branch path incidence matrix. So for that you need to draw the graph once again. So we will draw the graph once again by seeing the problem which was already given to us. So this was the problem 0, then let us see the graph once again 0, 1, 2, 3 and in this way. So we shall draw the graph once again, and while drawing the graph, this time we have to draw only the branches. Okay. So this time we have to draw only the branches. So let us draw the branches. So this is our 1, this is 2 and this is 3. Then these are our branches. So we will draw the branches one by one. This is 1. Then this is our next one. And this is our next branch. So please check the directions as well, because if the directions will go wrong, then your answer will also go wrong. Okay. So this is what our system is. With the help of this, we have to make our matrix K. So we have already written this matrix K in one of our previous problems. So what is the K? K is the branch path incidence matrix. So here in this case, what will be the number of paths? Number of paths will be equal to number of branches. So this you have to remember. So number of paths will be equal to number of branches. Okay. So number of paths will be always equal to number of branches. So here you know what are the number of branches. Number of branches are 3, that is 1, 2 and 5. So one by one you have to go to those branches and you have to draw the path that branch is making with reference to the reference point. So let me draw the path one by one. So the path which will be followed by this one will be in this way. So I will give this name as 1, and then this is 2. So this 2 will be in this way. And similarly path number 3. So in this way there will be 3 paths which will be there in this particular matrix K. Okay. So in this way we have to make this matrix K, and while making the entries of this particular matrix, what we have to do is, I don't think there is. So now what we will do, we will start filling the columns of the 1, 2 and 3. So who will tell me what will be the entry of the column 1?
Yes, sir.
And the last one will be only 5, that will be minus, and rest will be 0. So please cross check your answer. Is it clear, everyone? Is it clear now? Okay. So in this way we have completed our third matrix, that is the branch path incidence matrix. So the third matrix, that is the branch path incidence matrix. Now the fourth matrix is basic cut set incidence matrix, and this matrix is supposed to be the most difficult matrix in the entire unit, right? So there will be many number of difficulties to make this particular matrix. So I have already stated very simple procedure in the previous problem, and in this problem I will state you a very simple procedure with the help of which you can write the branch path incidence matrix. Okay, so let us draw the branch path incidence matrix. So for drawing the branch path incidence matrix, which will be our fourth matrix, branch path incidence matrix, and which is denoted by the letter B. So branch path incidence matrix it is denoted by the letter B. So for this we need to draw the graph once again. So let us draw the graph once again, and in your copy please draw this graph somewhat readable or somewhat big. Otherwise, if you will draw a very small graph, then probably you will not be able to cut your cut sets, and you will not be able to discriminate between the elements and the branches, and your answer may get wrong, right? So please draw the graph somewhat large so that you can make the cut sets visible and write it properly in your copy. Otherwise, you will find it difficult to write the things properly. Okay. So first I have drawn the branches. So these are my branches 1, 2 and 5, and then I will draw the links. So these are my links 3 and 4. Please don't forget to check the directions which is given in the problem. If you will make the wrong directions, then your answer will become wrong, right? So please don't do like that. Whatever direction is provided in the given numerical, take that directions only. Otherwise, you will end up with a wrong result. Okay. So this is the graph which is provided to us. Now what we have to do is we have to cut the branches. And while cutting the branches, please make sure the branch which you are cutting, with the branch there should be other combination as link. You should never cut a branch with another branch. Is that clear to everyone? You have to cut the branch with the links. Don't cut branch with branch. Okay? Is it clear, everyone? Is that clear to everyone? Cut the branches with only the branches. Never cut the branches with the links. So what are the branches here? The branches are 1, 2 and 5. So I will cut 1 in this way so that 1 and 4 gets cut, right? Because 1, if you cut the 1 with 5 in this way, you can cut the 1, 5, 3 also. But this is the wrong pattern. Why? Because if you will cut in this pattern, then 1 will cut with 5 and 5 is the branch, right? So a branch should never cut with another branch. A branch should always cut with a link. Is it clear, everyone? So please don't get confused while cutting this basic cut set, and give the name of this basic cut set with reference to the branch which you have cut. Like you have cut branch number 1, so the reference direction of this branch will be the direction of your basic cut set, and give the name as 1 to A, then 2 to B and 5 to C in sequence. Don't break the sequence. If you will break the sequence, then you will end up again with a wrong result. Okay. Then what I will do is I will make use of another color for the cutting of 2. So I will cut 2 in this way so that 2 and 3 gets cut with each other. Now the direction of 2 is towards right. So I will put the direction of my basic cut set and give this name as B, because this is the second branch, right? And in similar fashion, what I will do is I will cut the third branch, which is element number 5. Now, while cutting the third branch, you have to be very careful. Why you have to be very careful? See, if you will cut 5 in this way, then 5 and 1 will cut. If you will cut 5 in this way, then 5 and 2 will cut, right? So you have to cut it in a very systematic way so that 5 should cut with the other link. 5 should never cut with the branches. 5 should cut always with the other links. Is it clear, everyone? And then you have to write the name and you have to give the same direction as the direction of the branch and give this name as third name, that is C. Okay, is that clear everyone? How you have cut the cut sets? Is it clear everyone? Because in each and every problem there, this matrix will be there. So don't get confused at any point of time. Otherwise you will end up with a wrong matrix. So let me fill the set of A. A has cut 1 and 4. So I will write here 1, 4. These entries have to be there in the basic cut set. Then B has cut 2 and 3. And similarly, C has cut 5, 3 and 4. Is it clear everyone? If there is any difficulty, please let me know so that I can clear your doubts and you can write the problem correctly. Then what we will write the matrix, the name of this matrix with the alphabet D. Then write the branches first. What are your branches? Branches are 1 to 5. So write 1 to 5. And what are your links? Links is 3 and 4. So write 3 and 4. And then here one by one write the name of your basic cut set that you have drawn. So the first basic cut set is A, the second basic cut set is B, and the third basic cut set is C. So in this way we have written the things, and once you write the things, first what you have to do, you have to put the entries to the basic cut sets first and then the links. So you will see that we have cut 1 for A, then 2 for B and 5 for C. So this will be always positive. This cannot be negative at any point of time. Is that clear everyone? This will be always positive. This cannot be negative because you have cut 1 and given the name A. You have cut 2 and given the name B. You have cut 5 and given the name C. So these three elements can never be negative. This will be always positive. Keep this in your mind very much clear and then start filling the other entries. Now for filling the entries in the column A, what we have to do, we have to go to this A. A means you have cut 1. So what you have to do is you have to go to the set A, and while going to this set A, you have to check whether something or the other is in common between 1 and 4. So what is the common between 1 and 4? Can anyone reply? Can anyone element 1 with respect to this node 1, whether it is incoming or outgoing? Because we have already kept this as +1. That means we have to put something -1, right? So what will be that? Very good. So incoming we have taken as +1. That means outgoing should be -1. So you have to check whether what are the elements which are incoming or outgoing to this node number 1. Whatever is incoming, that will be positive. Whatever is outgoing, that will be negative. So what is this position of 4? Position of 4 is also incoming to 1, isn't it? So this 4 also should be 1. Is it clear everyone? So you have written A as 1, 4. You have filled 1, 4. That means this entry is done. Now let us go to B. So in B, what is common? Please tell me, what is the set of B? The set of B is 2, 3. So what is common in between 2, 3? Yes, make it quick reply. Very good. Node number 3. So now for node number 3, we have already made this 2 as positive, right? So what is this 2 to this node number 3? Please reply fast. We have made this 2 positive already. You can see here, we have made this 2 positive. That means we have taken which thing positive, incoming or outgoing? We have taken this 2 as positive, right? And this 2 is incoming to node number 3. That means what should be positive? Incoming should be positive, right? So incoming positive means outgoing should be negative. That means here 3 should be negative. Is that clear everyone? How we are taking negative and how we are taking positive? This point should be clear. Then only you will be able to write this particular matrix in the correct way. Otherwise you will end up with a wrong solution. So don't end up with a wrong solution. I am here to clear all your doubts. If you will ask me, I will clarify all your doubts. Right? The difficult portion is 5. क्यों? क्योंकि जब हम ये 5, 3 और 4 देख रहे हैं तो हमें 5, 3 और 4 के बीच में तो कुछ भी कॉमन नजर नहीं आ रहा है क्या? बताओ मुझे। 5, 4 और 3 या 5, 3 और 4 इसके बीच में हम क्या कॉमन ढूंढे? बताओ, हमें कुछ भी कॉमन दिख रहा है क्या? यस, बताओ मुझे, हमें कुछ भी कॉमन दिख रहा है क्या? नहीं दिख रहा है ना। तो अगर हमें कुछ भी कॉमन नहीं दिख रहा है तो हम ये 5 जहां से स्टार्ट हुआ और जहां खत्म हुआ दोनों में से कोई भी एक पॉइंट को कॉमन ले लेते हैं और फिर देखते हैं कि क्या हो सकता है। राइट? सो जब ऐसी सिचुएशन आती है, whenever this type of situation will come, when you will not be able to find what is common in between all these three, then what you have to do is you have to take either starting point or end point, both of either of these 2 points as common point, and then start searching what to do with the outgoing and the incoming. Is it clear, everyone? Tejaswini, is it clear now? Whenever there will be such situations when you will not come to know what is common point between the elements, then what you have to do is simply you have to choose either the start point or the end point as the common point and then work out accordingly. Here the starting point of this element 5 is 0, node number 0, and the end point is node number 6. So we can take either starting point that is 0 or end point that is 2 as reference node or common point, because we are helpless. We cannot take any of the point as a common point because there is nothing common in 5, 3 and 4, right? So in such situation what you have to do is you have to choose either 0 as the or the starting point as the common point or the ending point as the common point. So what I am going to do here is I am going to take, suppose this starting point as the common point. You can take any point, no, there is no issues. You can take either this point or this point as common point and start solve accordingly. You will get the correct answer. Okay. So I am going to take this start point as the common point. So for the start point as the common point, if we will check, we have already made this 5 as positive, right? So what is this 5 for this 0? 5 is outgoing for this 0. Alright. So if 5 is outgoing, that means from 0, whatever point is outgoing, that will be positive, right? And whatever point is incoming, that will be negative. So this 3 is incoming. That means what should be this 3? This 3 should be positive or negative? This 3 should be, yes, please reply fast. What should be this 3? This 3 should be positive or this 3 should be negative? Very good. So 3 should be negative. So let us make this 3 negative. So I have made this 3 as negative. Now what about this 4? So this 4 has started its journey from 2, right? So if it has started its journey from 2, so from 2 it will come to 1, and from this 1 it will not go back to this 2, but it will come back to this reference node 0. So what should be this 4 then? This 4 should be incoming to this node 0, right? So this 4 should be incoming to this node 0, right? So as this 4 is incoming to this 0, that means 4 also should be negative. Is that clear to everyone? Is that clear to everyone? How we have taken this 4 as negative? Because this 4 has started its journey from 2. From 2 it will go to 1. Again from 1 it will go to 0 because it cannot go back to 2, right? So as it cannot go back to 2 because it has started its journey from 2, it has definitely to come to this 0, and if it will come to this 0, then for this 0, this 4 should be incoming, and as we have taken outgoing positive, incoming should be negative. Not able to take the common point between the elements, you have to apply this particular logic. Is it clear, everyone? Okay. So what about rest of the fields? Rest of the fields we will simply put it by 0. Okay. So this used to be the most difficult matrix among all the 7 matrices. So this matrix is to be clear to all. Otherwise, you will not be able to make this matrix correctly. If you will, I am explaining each and everything in a very simple manner so that every doubts of yours should be getting cleared. Okay. Now the next matrix is the fifth fifth matrix, that is the augmented cut set incidence matrix. And augmented cut set incidence matrix is written by B dot. I am not writing the complete name here. I have already written this name previously. So what you have to do here is you have to write the previous matrix from the uh, B and then add the number of link to the portion of the previous matrix that will complete your B dot, which is the tie cut set or the augmented cut set, right? So up to C it will be same. Up to C it will be same. What you have to do is just a moment. Then we have to write here A, B, C. This is the same as that of the previous matrix. So you have to copy the things from the previous matrix. Okay. So what we were doing, we were simply writing the basic augmented cut set incidence matrix. So just we will complete it. So while writing this augmented cut set incidence matrix, what we have to do is we have to copy the contents of the previous matrix, that is the A, B, C part. We have to write it as it is, and then we have to write the two more set that will be related to the link. So here, as we know that we have two links, so we have written D and E over here. Okay, so D and E we have written, and this D and E needs to be filled here. So this E we have to put it round here, and then we have to consider the entries of this line in this way. So we will take B dot is equal to 1, 2, 5, then 3, 4. Then copy the entire contents of the B matrix as it is, and then add two more columns because there are two links for this problem. So we will add two more columns over here, that is D and E. So just copy the content of A, B and C from the previous matrix and then add the contents of D and E. So for D and E, it's very simple for us. For D, we will be giving 3 as the name, so 3 will become positive. And for E, we will be giving 4 as name, so 4 will become positive. Rest of the things we have to copy it from our previous matrix. So previous matrix 1 and last is 1, so we will take 1 and last as 1. Rest all things are 0. Then here 2 and 3 is there, so 2 is 1 and 3 is -1. So this we have taken the entry, and last is the 3 columns, that is 1 -1 -1. So we will take here as 1 -1 -1. Rest all the things are to be replaced with 0. Okay, so this will be your matrix B dot. So this is our fifth matrix. B dot.